Okay, no quizzes or tests due this week. We just have homework. So we have 5B due today. We have 5C, which is what I'm teaching today, is going to be due on Wednesday. So right before Thanksgiving break. When we come back from break though, be aware that you've got quiz 7 due on Wednesday, and then the buying versus renting project due next Thursday. So buying versus renting project is a big project, I'm not gonna lie. But most of it follows a really nice step-by-step list of instructions. So hold on, let me get into Eagle Online here. I'm going to start off talking about it so that I don't miss a chance to talk about it later in class. So in our course page in Eagle Online, you go down to Unit 5, and we've got the buying versus renting project. It walks you through the steps. They're really nice structured videos. It's going to go through the steps. I last updated these 12/3 of 2019. I don't think the project has changed a lot since then, if I remember correctly. My guess is it hasn't, or else I would have done new videos. But so the project is in your notebook on page 165. And it's very formulary. And so what I'm saying is, like, there are distinct steps that you are going to follow. The reason why the project comes at this point in the unit is because the amortization schedule skills that we're going to talk about here in 5C is what you build off of to do the buying versus renting project for the buying portion. Now, let me preface all of this. I know, especially in the age of insane real estate prices, this project was a little more reasonable in terms of applying to the Flathead Valley when I developed it a few years ago. And in the last year and a half, the whole region, the whole state, let's be honest, has exploded in terms of real estate prices. But we're going to just keep with the numbers instead of making us all really depressed about how unaffordable real estate is. So keep that in mind. So yeah, any questions about the project? Really, if you watch the videos, you're gonna feel like you know what you're doing, okay? It really will step you through. It'll seem like it's really convoluted, but then there's just a couple of reflection questions that you have to do. And then next week I'll talk about making sure you turn in all the right stuff. So again, how-to videos on the buying versus renting project right here. We've got extra copies of the instructions and the different layout pages. You'll notice in the buying layout, this is in your notebook as well. Your columns are going to go from, in column A, you're going to go months from 1 to 360, because that's your amortization part. And then the years in column H need to go to 30. And then you'll notice that this project is huge in terms of it's a really big Google sheet, because it ends up going all the way to column Y. So know that when you're looking at these are just continuations. So we've got column J is that first page. And then when you go to the second page, column K is going to start right after it. But I obviously can't put it all on one page because it's giant. And a lot of this stuff you'll see as you watch the video, you'll enter it once, you'll double click, and it'll fill down for you. So this is all of the buying section. And then we've got, wait for it to load, the renting pages, which is significantly smaller because we're renting. There's not as much that's involved there. So you'll notice column A needs to go to 30 because we're looking at 30 years. I know it cuts off at 29 here, but you need to make sure yours goes to 30. And then there's only one page because it only goes to column J. And then in your notebook, you'll notice on page, let's see, page 167 is where your reflection questions are. Number 1 actually has to do with this column J stuff here on the renting tab, you go to page 168. It's where the other reflection questions finish. If you want, you can just add a third tab in your Google Sheet and answer those reflection questions right in Google Sheets. You don't have to worry about doing a separate PDF document or Word document or anything like that. Just add a third tab, label it additional questions, easy peasy. Make sure, again, when you submit it, you're submitting the link to your Google Sheet and not like a downloaded Excel file, because that makes my life harder. But again, we'll touch on that when we come back from break. So before I move off of the project, any questions for me about the project? Let me stop sharing.
I know you just mentioned this. I forgot to write it down, but when is this? What's the date that this is due again?
It's due Thursday, December 2nd, which is insane to say out loud. How is it almost the December, which means 2021 is already almost over? Is that
probably good to work on this weekend, I'd imagine.
Yes. Yes, if you have the time, I highly suggest it. If you don't, I also understand, right? Like, it's Thanksgiving, right? We're all busy. But if you have time, I would suggest working on the project. It'll just make your week easier afterwards, because we do have a quiz due that week. So, and speaking of, I got your tests graded over the weekend, and I got your feedback uploaded. If it's still having issues with you not being able to see your feedback in Eagle Online, if you go into your grades, you get on the test and you look on the side, and there should be a link there to a document. If you still are having issues seeing that, please let me know and I'll email your feedback to you. Because I don't know, Eagle Online doesn't like me when I try to share documents for some reason. So again, if you can't see it, please let me know. But also in my math lab, I set it up so you could go back in and review your exams. So you know how you go back and you look at your grade book, I believe is where it is in my math lab, and you click on it and then it will show you the assessment again. So then you can see what you got wrong and compare it to what my written work is. So, any other questions? Okay, let's talk about type C. Let's get into that. So the first thing we're going to look at is that payment formula. It is a beast, but it's really useful. So I'm going to share my whole screen with you because we're going to end up using the calculator for a lot of stuff. All right. So I kind of talked about this in class on Wednesday last week. So we've got the payment formula, and there's a whole bunch of pieces to this formula. So we've got PMT, which just means payment, and it's equal to the principal P times your APR over N. And remember, N is your compounding periods. And this ends up giving you your rate per compounding period, right? This is what we were doing when we did the Google Sheet last week. T is your number of years for your loan. And so we've got our numerator and we've got our denominator. When you're entering this into your calculator, make sure you put the numerator in parentheses. And then you're also going to want to put this exponent in parentheses. So when you're thinking about how am I going to enter this into my calculator, you're going to do parenthesis P times APR divided by N, and parenthesis, division symbol. I'm putting it linearly like this because this is how you would put it into the graphing calculator. And then we're going to do a parenthesis 1 minus 1 plus APR divided by N, and parenthesis, caret key, and then negative N times T, and parenthesis, end parenthesis. So making sure that you can't see it because I have the calculator over it. There we go. So making sure you put this in this way is going to give you all of your parentheses where they need to be. It's going to make sure that you're giving it the order of operations it needs to calculate this properly, and you should get the correct answer. As you can see, there's a lot of nesting parentheses. It's easy to forget a piece. So if you need to write this out to help remind you how to do it, I totally understand. Hence to me writing it down for you, right? Okay, so it says, suppose that on January 1st, you have a balance of $6,100 on a credit card whose APR is 14%, which you want to pay off in 1 year. Assume that you make no additional charges to the card after January 1st. And then it says, calculate your monthly payment. So let me zoom out just so we can see more of this. So first of all, our principal is going to be the 6,100. Our APR is 14%, which we're going to put in as 0.14. And because all credit cards and loans compound monthly, N is going to be 12. And again, you can see up here, number of compounding periods, it's usually 12. So if we write out how we're going to put this into our calculator, to calculate our payment, we're going to do 6,100 times 0.14 divided by 12, and parenthesis, division, 1 minus, 1 plus, 0.14 divided by 12 to the caret key of negative 12 times 1. The reason why we have 1 here is that we're paying this off over 1 year. So we're looking at what does our payment need to be for that specific year. So if we pull up our calculator again, let me switch it to the other side. We're going to enter this. So again, making sure that we use our parenthesis. I want you to calculate this yourself to make sure you come up with the same answer. We're going to do 6,100 times 0.14 divided by 12, and parenthesis, division, 1 minus, 1 plus 0.14 divided by 12, and parenthesis, caret, parenthesis. That negative sign in front of the 12, you have to use this little negative down here that's in the parenthesis. Don't use the subtraction symbol. It'll make your calculator mad. And yes, I know 12 times 1 is just 12, but let's get into the habit of doing the times 1, just so when we go to do this with a different time period, we know that that's where our time needs to be. And so on the end, really common mistake is forgetting that second parenthesis, because that ends the entire denominator. And then when we press enter, we get that our monthly payment is $547.70. We're rounding to the nearest penny. So any issues with calculating that on your end with the calculator? So then part B says, when the card is paid off, how much will you have paid since January 1st? So remember, our payment is not just the balance over 12 months, right? We're paying interest as part of each of these payments. So in order to calculate part B, we're going to take $547.70 and we're going to multiply it by 12. So 547.70 times 12. Not doing what I ask it. gives us $6,572.40. Again, we are overpaying our loan, i.e. our credit card balance, because the bank is going to be like, you're giving me my interest. I want it. You're not getting out of it, which is why it's beneficial when you get those credit card offers of like 0% interest for balance transfers for a year. If you know you can pay that off, transfer that balance to a new card, pay it off over that year, and then you're going to save money versus if you continue to make the payments on your own, on the original balance credit card. So part C says, what percentage of your total payment from B is interest? So what we're doing is we're finding the difference. We're doing that same thing over and over we've done every time. Find the difference compared to the original amount, or not the original amount, the overall payment times 100 will tell us. So what does that look like? We take our new balance minus the original balance, not adding an extra zero though. And it says what percentage of the total payment. So we're comparing that to the total payment, which is why our denominator is going to be $6,572.40. And then of course the old multiply by 100 part on the end, because we want to convert it to a percent. So go ahead and do that calculation and let me know what you get to the nearest whole percent, or the nearest 100th of a percent. Okay, so when we calculate this, we end up with, let's see, 572.4 minus 6,100 divided by 6,572.4. So we get that, right? 0.0718, blah, blah, blah. Then we have to times by 100 to convert it to a percent. So don't round until you've converted it to a percent. And again, I'm asking for the nearest 100th of a percent. So that means we're going to have 7.19%. So in your homework, it asks you to find out how much of the total payment went to interest and how much went to principal. So if it's 7.19% went to interest, then principal, oh, whoops, it's PAL, not PAL, is 100 minus 7.19, which gives us 92.81%. And the homework questions that ask it like that are just about all of them, right? So you're gonna, and they only want you to round to one decimal place for the percentage or for the interest rate. So, but yeah, 1, 2, 3, 4, 5, they all ask it. So you find out how much you did in interest, subtract that off of 100, which gives you what you're doing for principal, okay? So as I was talking about on Thursday, Wednesday, I forget, whatever day we saw each other last Wednesday, right? It's a really good idea to know going into buying a car what you want your payment to be. And so this Google Sheet will actually help you to calculate your payment based upon the number of years you want your loan to be and the possible interest rates. So we're going to buy a new car. This is obviously pre-2021 where new cars went through the roof and money means nothing anymore. This is back in 2019 when things all made sense, right? So you want to buy a new car that costs $17,250, including closing costs. You have $2,250 in your savings that you can use as a down payment, so you only have to borrow $15,000. Before you go to the dealership to buy the car, you want to know what your monthly payment will be at different interest rates for different lengths of time. So we're going to create this Google Sheet. So bear with me while I set up my screen again so that we can see the sheet and the other part together. So give me 1 second. Okay, so we are going to enter a single formula right here. And entering this formula here in location C7, we are going to enter it using cell locations and fixed locations, so dollar symbols in certain places, right? So that we can fill that equation horizontally and vertically. So the payment formula is a long one. So I'm just going to write it on the left here, and then I'll explain what all the pieces mean to you as we're putting it in. So we're going to do equals negative PMT, and then $B7 divided by $B$2, comma, $6 times $B$2, comma, $A$2, comma, 0. So what does this all mean? So $B7 is fixing column B with the interest rate. So it's taking our interest rate and dividing by 12, because you can see that number 12 is in location B2, because that's the number of compounding periods in a month. So it's finding our period rate. The next part is it's saying C6, that's the number of, so it's, as you can see, it's doing column C, but fixing row 6, which is right here. And what that's doing is it is allowing for our number of years to change, but it's fixing it that row C. So now it's taking our year number and again multiplying it by 12, because it's telling us how many payments we're going to end up making over the course of our loan. So this part is our period rate, which is taking our APR dividing by 12. This second part of this function is calculating the number of payments we're going to make. $A$2 is the principal. And then the 0 is our ending amount. So what Google Sheets does is it takes all these pieces of information and it calculates out using basically that payment formula we use, but it goes on behind the scenes, okay? So if we go to our Google Sheet, we're going to do equals negative PMT. Oh, the other thing, the reason the negative piece is in there in this is because I want my payments to show up as positive amounts. Normally, the payment formula is used as part of your amortization schedule, and it comes out as a negative amount because it's going to be subtracting off of your account balance each time, which we will see in the second Google Sheet that we're doing. But I just have the negative portion here so that we have a positive payment amount, or else it's all going to come out negative and you're not going to understand what's happening, right? And be like, why do we have negative payments? Normally we do have negative payments. So let's see, $B7. Fine. $6. Oops. And then you look and see, did I make a mistake? And oh, look, I put a number sign and not a dollar sign. So go back and fix it. And again, this yellow part, that's taking our percentage rate, dividing it by our number of periods. The blue is the year times the number of periods. The red is our starting amount, and then we have 0, which we want it to go to. So I'm going to say no on the suggested fill. What this is telling us is that if we were able to get a 1% rate on a car loan for 1 year, our monthly payment would be $1,256.78. Now, we are going to fill this horizontally. So you can see as the number of years goes on, classics car loans are 60 months, which is 5 years. 6 years would be 72 months. I actually at one point in my life had a 66-month car loan because that's what worked for my finances at the time, right? At this point in my life, I choose to not go beyond the 5 years, but that's because we drive an obscene amount of miles and like we end up owing more on our car than it's actually worth because we drive so much. But that's my own finances. So at 1%, we double click and it fills down and it gives you all of your different payments based upon the rates. Like I said, when we bought our car a couple of years ago, I did this, not with this many rate amounts, but I did break it down because I knew at the time what banks were offering. And so like we went and got pre-approved at a certain rate. And so then I played with the numbers to see based upon what the car dealership, if they were going to match it or beat it. Because most likely you're not going to get a nice percentage rate, right? You're not going to get 2% or 3%. It's going to be like 2.99 or 3.25 or who knows, right? It's not always that nice, but you can then change these numbers if you want, that will then cause all of this information to change. So the next question says, how much total interest do you pay with a $289.99 monthly payment? So we have to go in and find that in here. So $289.99 lives right here. This is in the 5-year 6% place. It's interesting. So currently we just associate car loans with having really low interest rates. I found loan papers of my mom's from the 90s when she bought a car, and her loan rate, because inflation the way it was in the 90s, she had a loan rate of like 15% on a car loan. And I was like, are you kidding me? And I knew she had good credit. It was just like, that's what they were back in the 90s. And thankfully we're not living in that world right now, but who knows? Inflation continues. We'll see what happens. So $289.99. We know that we're making it for 5 years at 12 months per year. So you could easily just shorten this to 5 times 12, which would give us 60. But in order to calculate interest, we first have to calculate what is our total that we're even paying. So we take 289.99 times 5 times 12. We get $17,399.40. So now to calculate the interest, we're going to take off the original loan amount. Giving us $2,399.40 in interest. So if we go to page 3, it says, how much would you save if you switched from the 5-year 6% loan to a 5-year 5% loan? So again, remember 5-year 6%. We had a payment of $289.99, which gave us a total amount spent of $17,399.40. So 5-year 5% is a payment of $283.07. So $283.07. We're still doing 5 years. So we're still multiplying by 12 and multiplying by 5. Gives us a total of $16,984.20. So to find our savings, all we need to do is subtract those two amounts, right? That's the amount we're going to save by switching. We save $415.20. So what if we switch to a 4-year 6% loan? So to remember, 5-year 6% is $17,399.40 for our total. So 4-year 6% is a payment of $352.28. Now to get our total, this is 4 years. So instead of multiplying by 5 and by 12, we want to multiply by 4 and by 12, right? Which gives us 16,909.44, which gives us a savings So what is a bigger indicator here? I want you to think about this, of what's going to cost you more in the long run. Is it time or is it interest rates? Because we can see in the first one, we change our interest rate by 1%, what it changes by, versus if we change our loan by a year and what that changes by. So we end up saving more when we knock a year off of our loan period, right? So if you can afford the higher payment, go with the shorter period of time if you can, right? Because that's what's going to be the bigger impact in the long run. So number 4, I'm going to let you answer this on your own. It says if you were forced to take out a 6-year 10% loan, how much would you pay in interest over the life of the loan? So 6-year 10% is a payment of $277.89. And I want you to send me a direct message with how much you end up paying in interest for that. So remember, for calculating over the life of the loan, that makes, we're taking this amount, we're multiplying it by 12, and we're multiplying it by 6. This is a 6-year loan, right? Which is going to give us a total of $20,008.08. So how much do we pay in interest? Well, that's the difference between what we pay total and how much we borrowed to begin with, which is a total of $5,008.80. So the next thing we're going to look at is the amortization schedule. And so what amortization schedules are they show you how much you're paying at each month and also how your account balance changes or your loan balance changes after you make those payments. So you'll notice on this page, we needed to make sure that we went from years 5 to 57, right? So we needed to fill in all these extra years there. So there's some big formulas we put in here. And we're going to fill in the pieces first, and then we're going to type it into the sheet. So first of all, we are going with as if we had the 5-year 6% loan. Okay. So the beginning balance is going to be what we're starting with. And so in this case, in section B5, we're going to put equals A2. And that is our principal here, this 15,000 amount, right? To calculate our monthly payment, we're going to do equals PMT. You'll notice that I dropped the negative from this payment calculation because I want it to remain that negative amount because it's going to subtract off of your balance amount. So we're going to do equals payment, $B, $2, divided by $C, $2. Again, B2 is your interest rate divided by the number of periods. So that's creating your periodic rate. And then we're going to do $D, $2 times $C, $2. Again, D is the number of years times the number of months, which is going to give us our total number of periods. So that $D, $2 ends up being 60. But we need to fix those cell locations so that when we use this formula and fill it out, it doesn't suddenly change the amounts. And then we'll do comma, $A, $2, which is our initial amount, and then 0 like we did before, because we're saying calculate this until you hit 0. For the interest payment, we're going to do equals $B, $2, divided by $C, $2, and then times B5. So $B, $2 divided by $C, $2 is just that 6% divided by 12, giving us our periodic rate. B5 is what that balance is. So it is calculating the interest that you owe based upon that balance at that moment. So columns D and E are showing you how your payment is broken up between what amount of your payment goes to the interest and what amount goes to the principal, because you better believe that the company is going to take all of its interest owed. So that's the other reason, and we're going to add this piece in here in a minute, is how does it change your loan if you start to make an extra payment or just add on a tiny bit, and how does that change how you owe over time? The last part is your principal payment. And this is going to be equals C5 plus, nope, not B, D, D5. So C5 is your monthly payment, which is a negative amount, plus your interest payment, which is a positive amount. So the difference is what gives you your principal payment. And when we're adding those together, The reason we add them is because one's a negative and one's a positive, so it's still going to give us a negative amount that's coming off of it. And then finally, our ending balance is equal to B5 plus E5. That is taking our beginning balance, taking off the principal amount, which gives us our new ending amount after that 1 month. And then we have to do in B6 the new balance, which all that means is take the amount that we have here in F5 and bring it down. So we're going to do equals F5. So we're going to put all this stuff into our Google Sheet. And we're going to then fill it in. So let's start typing this business in. Oops. Oh, whoops. Hold on 1 second. There we go. I was off a location. There we go. My original amount for the interest is saying I was only paying $1.45 in interest, and I knew that was way overpaying way more than that. So you can see after that first payment, our balance is now $14,785.01 because we made principal payment of $214. So now we're going to return this new balance amount. And then we're going to pull each of these down 1. Oops. And the purpose of pulling them down 1 is I can now highlight from B6 over to F6, double click on this blue box, and it's going to fill my whole amortization schedule in for me. And you'll notice it does come out to $0 after 60 months. Great. That's what we wanted, right? So I'm going to pause for number 7 because I want to talk about what happens if you want to pay extra. Okay. So I'm going to insert a column to the left. And I'm just going to label this extra principal. So let's look at this. Our payment is $289.99. All right, let's do $11.01. Why does that? Why would I want to do that? Well, the reason I'd want to do that is because that makes my payment $300, right? Okay, so let's change this because we want to add these amounts. Now, we don't want this to be a positive amount. We want it to be a negative amount. because we're taking it off the principal, okay? So now with this ending balance, let's add in F5. And you see it's knocked down my principal a little bit more, right? Okay, so let me delete this. I'm going to show you how this changes over time. And let's fill this in. So if we do this, you're going to see right here, we end up with negative amounts, which means by adding in $11.01, we pay our loan off basically 3 months sooner, right? Okay, so what if we increase our amount to, I don't know, be wild, $31 extra, okay? Now we're paying our loan off 6 months sooner, right? So paying that little extra, just making an extra $31 payment does in fact bring our loan amount down more quickly, right? Because you end up paying off that interest more quickly. So the more of your payment, as you can see here, more of your payment ends up going to the principal, it'll pay it off, okay? And you can play with these numbers to find out if you just make the amount over 1 year that's equal to 1 extra payment, how does that change the amount and that kind of stuff. So I need to renew this because it's messing with our stuff to be able to answer the rest of the questions. I just want to show you how you could add that in, okay? So let me delete the column. Oh, I know you're mad at me. Get over it. There we go. Okay. So now let's look at question 7. It says, how much interest do you pay over the 5 years? So we already know this from our previous amount. We know our payment here is $289.99, which we make over 5 years and 12 months each year, which gives us a total of $17,399.40. So this is our 6% loan. And so the interest is $2,399.40, right? So the question says, how does lowering the APR to 4.5% change this answer? So in your Google Sheet, all we have to do to calculate this, if we're playing with different APRs, is right here in location B2 is type 4.5. And that will automatically adjust our entire Google Sheet. So you'll notice I changed it from 6 to 4.5 and suddenly our payment dropped to $279.65. So if we do 4.5%, we now $279.65 is our payment, which we multiply by 5 and we multiply by 12, which gives us a total of $16,779 even. So if we wanted to look at just the interest, We can see that it's $1,779 even instead, which therefore the savings, and there's two ways we can calculate the savings. We can just subtract the amounts that we pay in interest, or we can subtract the total amounts. We're still going to get the same answer. We get a $620.40 savings. So 5C is honestly my favorite thing in this class, because I think it's like the thing everybody walks away with going, oh my God, thank God, now I know what I'm doing, right? So obviously use this in the future. And when we bought our home, I calculated what our payments were based upon different amounts. The hilarious thing is that when you buy a home and they print out the loan documents, they print the full amortization schedule. On a 30-year loan, that's a really long time period. And I was laughing at we were signing the papers. I was like, really, you guys print this? Like, that's like reams of paper practically. And she's like, yeah, we have to print it and give it to you. And I was like, all right. But anyways, I just find loan stuff fascinating because I didn't talk about it with my family as a kid. Like, I didn't know what finances were and everything. And, you know, it's trial by fire when you become an adult and you have to do all this. So any hoosies, that's 5C. The amortization schedule that we just did for the car loan, you do a much bigger one for the home ownership, but it just goes more month, right? The columns themselves don't change. Then none of that is different. So that's the beginning of your buying versus renting project. So Luke, did you have a question? I saw you unmute yourself.
Oh, no, my finger accidentally touched it. But.
Oh, okay. So that's all I have for today. On Wednesday, I will get into 5D and begin 5E. We did a lot, so I'm not going to force us to work another 20 minutes. We'll just talk about it on Wednesday.
That is why it's so crucial to double, triple, quadruple check the paperwork for fixed interest rates on homes, because man, yeah, 7% not so bad until they jack it to 18% because of the market. And
that whole, I mean, that was the whole thing that happened in 2008 was they were doing these variable rate loans. And so then these people had these huge balloon payments because at first it was like, oh, this is great. And then suddenly their rate went way high versus, yeah, a fixed interest rate. I mean, it's crazy, the criminal practices that people, and by people, I mean, companies were able to, do.
Yeah, that the banks could legally do that. It's like you were purposely setting them up for failure. Like they are your get out of jail free card. I mean, yeah, it's sick.
Well, and the fact that the whole thing that happened with the selling of the junk bonds when they were packaging everything together with these really terrible mortgages, and they're doing it again. And like, they're just hoping that nobody pays attention to these short sales that are happening. But oh my gosh.
Yeah, they tried sweetening the deal on us with the whole variable. And I was like, no, man, I don't even care if it's like 5% over what we want. Like, it's got to be fixed, period, in writing. Like,
exactly. I don't want to talk to you if it's not fixed. Yeah. I know my husband gets all these things in the mail of like, refinance your student loans, variable rates versus fixed rates. And I was like, in what world would we choose the variable rate? You guys are full of it. But anyways, money, it's the worst, right? You all know you're going to school. It's so painful. You're like, I know this will set me up for the future, but right now I don't want to think about it. Oh man. Well, on that very uplifting note, I hope you all have a good rest of your day. I will talk to you all on Wednesday. In the meantime, email me if you have questions, okay? All right, bye-bye.